Good afternoon, and let's begin today's course by looking at couple first. For couples, we know that for couple we have one force going to the right and one force going to the left, and the total force, the resultant force on the rigid body is 0, right? And in this case, we only have rotation and we do not have translation, right? And in this case, we have one force. We have the total force acting on the rigid body is equal to 0. But most of the time, or usually, the total force acting on a body is not 0. And we begin by from the top left-hand side. We begin here. Now, and suppose we have point O here. Point O is our center of gravity. Let's say, I think you have learned this at high school physics, right? So we have center of gravity here. Now, we have one force. We have only one force acting to the right, F. Sorry, and please put it. I think we have one force to the right, F, acting on point A, and of course, this line of action is here. Let's say we have one force F acting on A, and the center of gravity. The center of gravity of the rigid body is located at O. So in this case, we have translation, right? Because F equals to MA and so on. And do we have rotation? Yes, good. So because the force, if the force acts on point O, then we don't have rotation. But because our force is acting on point A, so we have rotation. Okay. So how should we go on from here? How should we analyze, or what should we do with this? Now let's make it this way, and we add two forces. Let's say this force is force 1. Let's say this force 1, and we add two forces. We add it here. We add one force to the left, and we add one force to the right, and all of them have the same magnitude. And the lines of action are parallel to each other. And we could say this is force 2. And we add two forces, one to the left and one to the right, and both of them are acting on points O. So for this problem, we have now we have three forces, right? And you can say, let me write it this way. And for the let me put it this. Oh, sorry. And we have three forces acting on the rigid body now. But you can see that force 2 and force 3 would force 2 is here, force 3 is here, and they cancel each other. Right? So they cancel, sometimes we say cancel on each other, but cancel each other is all right. So these two, force 2 and force 3 cancel each other. So if we say we have three forces acting on the rigid body, actually it only means we have one force, right? It is the same. If we have only one force acting on the rigid body, it's the same as we have three forces, because these three forces, this force 2 and force 3 cancel out each other. Is it okay? But now we look at the problem from a different angle. We look at the problem differently. Now we do it like this. Let's consider this. This is we look at the problem like this, and we say we have we consider these two first, and then we add force 3. Okay. We consider these two first, and then we add force 3. Now, for these two forces, and what is it? We have learned this, and because force 1 is to the right and force 2 is to the left, and the magnitudes are the same, their direction are opposite, and the lines of action are not the same, but they are parallel to each other, so it is a couple, right? If we only look at forces 1 and 2, okay? So this one is now alone, and this is a force. Now we can determine the magnitude of this couple, and I think this should be easy for you. And now we have R. If we mark R here, if we have R here from point O to point A, then the magnitude of the couple is the magnitude of the couple is now. Let me first write O here, but of course, we don't need this. It's equal to R cross F. And on top of that, we have we need to consider this. Remember, this is from 1 plus 2. No? This is from 1 plus 2. And we still have force 3. So we have this one F here. Magnitude of it is F. This is from 3. So it's sort of like magic, and we originally we have one force acting on point A. But if we look at everything from the center of gravity O, so O is here. If we look at everything from the center of gravity O, that we have one force and we have a moment here. Right? We have a force and we have a moment. So, and for this thing, wait a minute. Let me have a look. Sorry. And so for this thing, we call this group force couple system. And remember, for a force couple system, it has two parts. One is F, and another part is MO. So we have a force couple system. Remember, for a force couple system, we have two parts. We have M and we have MO. And if I ask you in the midterm examination that to determine force couple system, remember we have M and we have MO here. That we have two parts to the answer. Okay, you may let's have a quick look of the difference between couple and force couple system. Now, remember for couples that it has for couples that the resultant force, all the summation of all forces on the rigid body is equal to 0. Okay, but now see for force couple system, for the things we are talking about here, the summation of forces, summation F does not equal to 0. Okay, in this case. In couples, then if we talk about only one couple, that the summation of forces, summation F equal to 0. But now the summation of forces does not equal to 0. It's okay. For example, if in later, if I have problems where the we are talking about one force and the summation of forces does not equal to 0, that's remember. Usually you need to write the force couple system, and you will have to write F and MO here. Now, suppose we begin from here. Now I want to, we have point O here, we have F and we have MO at this point A. But we want to put everything at point B here. Oops. Should I use another color? point B here. Suppose we want to put everything at point B. We don't want to put things at point O. So how should we do this problem? We divide the problem into two. We divide the problem into two. And we divide the problem into the part of F and divide the part of O. Okay? Oops, I think I should. Now, and originally, at the beginning, we have F here, and now we want to move everything to point B. So what should we do with this single force F and we move it to point B? We use the same method as here. We use the same method as here, and we simply put two forces here, right? Oops. And suppose the moment's arm is S here. So what do we have? What will we get? We will get from point B we have F, and then we have MB equals to S cross F, right? This is one part. Now for the other part, and we only deal with we only talk about MO. Remember, MO itself is two forces with the same magnitude, right? With the same magnitude. So for MO itself, it is summation F equals to 0. So and it is independent of reference points. Okay, my writing is not very good, but so our MO can be moved directly to point B. We can move it directly from point O to point B. And we put it back to the system. It means that this thing should be added to here. And we have MO here. to okay. Is there anything I am not writing clearly enough? You can raise and ask in Chinese if you want. Anything you can't see clearly? 这里上去还是这里？哦，OK， 好。哦，对。This one, no. Yep. This. You mean this one, right? Okay. It's sorry, I should write it clearly here. Okay. It's okay. Now, to summarize what we have done in the past, say half an hour. Now, to summarize. And what we have done is like this. First, we have a force acting on the line of action along. We want to express this force on along the line of action O and O prime, and along point O. Therefore, we will by the free force method on the top of the page, we will arrive in we will get F, and we will get MO here. This is called a force couple system. If we want to move if we want to express the force on another line of action, say through point B, and we first consider the force, and it will become a force and a couple through point B. And we have the original couple from point O, and then we move it directly to point B. So for this force couple system, MB is equal to S cross F plus MO. Is that clearer? If you are okay, then let's do an example, and I hope it will be better. Now we have four forces. We have four tuples, and tuples are these small ones. These are tuples. These are tuples, and are used to bring a large ship to the pier. Pier is this one. Now, and for each tuple, and it can exert or it can act a 5,000 Newton force. Of course, the directions are all different. Now, determine the following. First, the equivalent force couple system. Equivalent force couple system at the point O here. Point O is here. And part B, the point on the hull is a single more powerful tuple should push to produce the same effect as the original four tuples. So I think the English is now clear. This one should be you can say this one is this one. Ocean Island. Okay. So now we have four smaller ships pushing different forces, pushing 5,000 Newton forces in different directions to the bigger ship, and we want to, of course, that for example, if this tugboat or this ship push on this ocean liner, it will make it turn this way, right? If only one ship, right? So we have another ship pushing this way, and we have this one and this one. Of course, these two will push it in the clockwise direction, and these two push it to the anti-clockwise direction. And we want to know the total moment due to the forces acting by these four tuples. Because you can see summation F should not be, here it seems that the summation F does not equal to 0, so we are not talking about couple, but force couple system. Okay. Now, and we denote first of all that we give them names. So we have F1, F1 to F4, F1, F2, F3, and F4 here. and it's okay. F1 to F4, and we have here and things like this. Is there anything you cannot see clearly? Should I explain any things on the screen? This bit. Should I? So then I think let me move on. So we have four forces. We have F1, F2, F3, and F4. Now we do them one by one. So we do them one by one. For example, we do we work on F3 here. Now, and F3 acts on the, let me draw here, and we have X and Y axis here. This is point O. Right. Now we have F3 and F3 here. And this is equal to minus 5J kilonewton. And so what is the distance between these two O and the line of action of F3? Distance is the distance between point O and the line of action of F3 is 30 plus 60 and plus 30 is equal to 120 meters. What we want now is to express, we want to express this at point O. So we move this to here. So we will have one force and then one couple. So should it go this way or we go this way? It seems we go this way, right? We have here. We have F3, and then we have MO3. Now, the thing now is to determine F3 and MO3. F3 is the magnitude is the same, so F3 is equal to 5J kilonewton, and MO3 is equal to R3 cross F3 equals to 600 kilonewton meter. It goes clockwise. Sorry. Then okay. So we do the same thing for F1, F2, and F4. You get force couple system at O. So the force will be F1 plus F2 plus F3 plus F4. And we will have the result is this one or this one. So, and for the next thing is the couple part of this, the couple part of the force couple system. Remember, we have force and couple, right? So our answer has two parts. One for the couple, and it is equal to MO1 plus MO2 plus MO3 plus MO4, and you can work out the other three, and it is on the textbook. Now it is equal to minus 310 kilonewton meter, which is, or you can write in this way. It's up to you. So if we want to draw it as a figure, and it is this one plus this one. I'm sorry. You don't need to draw this part, and it is already here. Okay. This is you can say this is R, and this is MO R here. Is that okay? Give me 5 more minutes, and then I'll give you a break. This is part A, okay? This is part A. And now we go to part B. What is the meaning of part B? It says the point on the hull where a single more powerful tuple should push to produce the same effect as the original 4 tuples. Now, it means we have only 1 bolt. We don't have 4. We only have 1. And but we want to we only have 1 bolt, but we want to produce the same effect. Wait a minute. You know this word, right? And or I should mark it down. So we don't have 4 bolts now, we only have 1, and we want to produce the same effect. So we have, of course, that the bolt is more powerful, and It's more powerful, but where should we put the force? Where should we put the force in? Now we have an unknown x here, because we should not put it here, right? And definitely we should not put it here, because if you put it here, then it will be going to anti-clockwise. But now we want to have clockwise movement. So we have and we suppose the force is acting here, right? And the force R is the same, but the original the force couple system R and MOR is now replaced by this one. It's now replaced by a single force. It means that our force for this force, and we have for this force on the point A, we have the moment arm R here, right? With respect to O. R is equal to OA equals to xi plus 21 j meter. The unknown is x here. The unknown is x. And what else do we know? We know MO is equal to R cross R is equal to minus 310.7 K kilonewton meter. Therefore, it depends on how you write it, but I write it this way. And we will get x is equal to 12.3 meter. This one is R, and this one is small r, this capital R. So after you copy this, take a break, and I will explain. I'll explain it. I'll explain all this after the break.